Hello guys, welcome to my channel, Mr. Jefferson 105. On today's video, I bring you a review about this filament. This filament is rPLA from the company called Filamentive. The company specializes mainly in recyclable materials. This is a very huge advantage over a normal PLA. I'm gonna go through several steps for you to understand. This is not just a review of the actual material. This is also a review of the company and what they actually do and what things they do to help the environment. Is rPLA the next thing? Let's find out.
Hey guys, a UK based company called Filamentive reached out to me to test and give my point of view of the recycled polylactic acid, also known as rPLA. The filament has a grey colour with a glossy finish to it, which I like in order to see how well a recycled material can print, as some of you have been asking. Is a recyclable filament as good as a normal one? Should I get one? Where can I get one? I will try to answer all this and more on the video with several tests. Let's start by understanding how Filamentive ensures a good quality filament. All the filament made comes from a recyclable source, which involves the recycling of waste from different companies and manufacturers. They also recycle all plastic spools. And did you know that you can get 20% off if you send them your empty spools on your next purchase? The materials that they recycle are rPTG and rPLA. In this video we are going to cover rPLA. Let's take a closer look. I downloaded a temperature tower from Thingiverse. Then I imported it to my favorite slicer, Simplified 3D, where I created a profile for my Prusa MK2S with the following parameters. If you want to do the same, you can get all the links and information in the description below. As you can see, it prints just like any other PLA, and your preferred slicing settings are going to work perfectly. Easy of use, not a problem here. I tried temperatures from 185 to 220 degrees, although the official recommended range from Filamentive is 190 to 220. For this test, I am mainly looking for sharpness, strength, and detail, corner sharpness and smooth of the surface. The corners are sharp throughout the temperature changes. The temperature finish is still glossy to the best quality that my MK2S can print. With regards to blobs, none were found in this case, although the G-code generated by my slicer had 3 noticeable retractions that could have appeared on the part, and they didn't. In addition to this, to see how well the layers were bonded, I ripped apart the temperature tower to see how I can break a single perimeter with just my hands. You can be the judge for the bond of the layers, but I believe is very good throughout all temperatures. Strength. The strength is good for it to come from a recyclable source, but of course there are other materials that do better in this criteria. Strength wise, I actually think it's top notch. If we keep in mind that the temperature tower was printed in a bias mode with only one perimeter, it is pretty good. I also printed some usable parts for my other 3D printer. The extruder was upgraded to a direct drive, allowing me to print flexible filaments. Moving to the y-axis, a reinforcement piece to help with the stability, and to help home the machine, an adjustable end stop for the z-axis was printed. Details. The details are very good, even in small parts such as this owl. As you can see, the details are mainly highlighted on the log, feet, wings and back, but as we can see, the peak did not print well due to the original file being scaled down. It was more a software problem than the material itself. The owl was printed at a layer height of 0.15 millimeters, extruded temperature 220 to 215 with a heated bed of 60 degrees Celsius. The speed was 60 millimeters a second with a flow rate of 100%, and the cooling fan at 100% speed after the second layer. The following section will be about the tolerance of the filament. To test the diameter, a piece of 6 meters in length was used to take 6 random measurements per meter. On the box, this is specified as 1.75 millimeter filament, but after my test I obtained an average of 1.734 millimeters, giving me a tolerance of 0.016 millimeters difference. Disclaimer: I could have used a longer length and more random measurements, for example 100 meters and 10 random measurements per meter. This would have given me a more accurate result, closer to 1.75 millimeters. Now let's move to adhesion. We know that normal PLA can adhere to a cold bed, whether it's glass or any sort of tape. In this case, I have printed a very small and yet intricate shape to test how thin of a wall my slicer can recognize. As you can see, there is a tiny bit of a fuzz, but it can be taken care of with a tiny increase in retraction. This part was printed on glass on my other 3D printer after the upgrades as described previously. Final thoughts. I really like the shine of the filament and how easy it was to load and unload without clogging the machine. The strength is good. I can say that the filament does what it says on the can. It does not have any significant odor either. I tested this by inviting some friends to smell the material while it was printing. Weird, right? It was the most honest way to find out if it produced any sort of a noticeable smell. 2 out of 6 said that they noticed a mild odor in comparison to the normal PLA, which it was 4 out of 6. To bear in mind, none of these guys have any clue about 3D printing. Therefore, I believe it is a pass with flying colors, don't you? Thank you guys very much for watching. Don't forget to give a thumbs up if you like the video or thumbs down, and please leave a comment so I can improve for the next time. Thanks guys.